Good afternoon and welcome to today's presentation, OSHA and Collaborative Robots in the U.S. market. In today's webinar, Will discuss definitions of collaborative robots, the practical use of CR systems in U.S. factories, OSHA-Centric risk assessment, CR technology and legal liability, and the primacy of OSHA in the U.S. market is affirmed. To give you a little background about our presenter, Vernon Mangold is currently the Vice Chairman of the AWS D 16 Robotic and Automated Welding Committee. He currently serves as founder and principal consultant for Kaysafety, an engineering firm. Mr. Mangold is the former president and CEO of KOHOL Systems, Incorporated. He has worked as an expert witness since 1984 and has 3 years of advanced automation industry experience. Attendees who require a passcode, the word for today is robot. During the Q&A session, we ask that you enter this passcode into the Q&A widget for CLE reporting purposes. The Q&A is located to the left of your screen. Please remember that if you are applying for CLE credit, you must log on to your computer as yourself and stay on for the full 60 minutes. You are also required to complete a survey at the end of the program. Please note that CLE credit cannot be given to those watching together on a single computer. Tomorrow morning, we will send out an email with the link to the archive recording of the webinar. The slides can be downloaded from the resource list to the left of your screen. Thank you for attending today, and Vern, the presentation is now turned over to you.
Thank you. Again, to reiterate, my name is Vern Mangold, and the title of today's webinar is OSHA and Collaborative Robots in the U.S. market. Let me begin by saying that this topic has been divided into two parts. One addresses directly collaborative robots and current case studies. The second half refers to a case that I have dubbed Blood on the Teach Pendant. What is special about this case is that it's the only case I know that's on the record where the courts decided who was of primacy, whether it would be OSHA or ISO. The reason why I include this case is because the issues are almost identical with the case study of the two collaborative robot injury accidents. But I'm able to speak about this because obviously it went to a verdict. So therefore, the materials are readily accessible, and I don't have a confidentiality problem. So many of the texts have a lot of material to it, a lot of content. Of course, you're going to have copies of that content. What I'm going to try to do on the more busy slides is try to give you an oral overview. We have two question periods, one at the end of the first half of the presentation covering ISO, OSHA, and collaborative robot background, and then a closing question session at the end of the presentation. With that, let me begin by, and this will be one of the few slides I actually read because I want to cover the scope in a comprehensive manner. We're going to take a look at collaborative lost-time injury access. In this case, collaborative robots have only been around commercially, I'm going to say arbitrarily, 4 years. And there'll be some debate about the precision of that number. But let's say approximately 4 years. And already, I have encountered 2 lost-time injury events that involve collaborative robots. Now, the definition of an industry consensus safety standard will be covered in the presentation today. And the conflict that currently exists between ISO requirements and OSHA. We'll talk about the 2 accidents. Now, again, neither of these cases have actually been filed yet, so I have to be somewhat careful since I'm involved about the confidentiality. I will talk about them somewhat in the abstract. And I've also addressed the OSHA perspective on collaborative robot technology, which might surprise you. And allowable incidental cutting and bruising, that theorem, which applies to the rest of the world but does not apply here to the United States. And a term of art that some of you may not be familiar with, LOTO, and that's an abbreviation for the term lockout tagout. which lockout tagout is a colloquial term, which really doesn't give justice to the fact that it's actually a federal regulation. Under the 1910 OSHA standards, there is a regulation called 1910-147, and the actual title of that regulation is Control of Hazardous Energy. We, in the industry, use the shorthand of using lockout tagout, or even shorter hand, LOTO. That is the general scope of today's presentation. And like I say, we'll have 2 different question and answer periods. So make sure to take your questions down as we go. There is some confusion in the industry that I'd like to clarify. What is an industry voluntary consensus standard? A consensus standard is a body of information that's used to help industry in many respects, recommended practices, to set design standards, for instance. And it's consensus in the sense that any organization that pursues a consensus standard follows a certain prescriptive standard for the production of that document, usually Robert's Rules of Order and other codified processes, to allow for the input of the entire industry, or at least make an attempt at that. Now, currently, these standards are usually produced by what's referred to by the acronym NGO, a non-governmental organization, and they've devolved from a country national standard. In other words, let's say you have a German DIN standard, or you have a UK standard. And then that standard then is then devolved into a broader standard, which is then incorporated into ISO. And then a process takes place to vet the document, to bring in the comments, so forth. And it's a common practice in the production of a consensus voluntary standard. Now, here is an important point. And this is one that sometimes escapes us here in the States. Industry voluntary means what it says. It's a non-mandatory set of requirements. Now, this is different than OSHA regulations. And to add to the confusion, unfortunately, OSHA sometimes refers to their document as a standard. That's just a fact of the semantics. The reality is they're actually federal law. It's federal statutes. It has the rule of law and the force of law. It is not an industry voluntary standard. To the contrary, it's an industry mandatory set of guidelines. And the 2 most significant NGOs from the U.S. perspective are ANSI and ISO. ANSI being American National Standards Institute, and ISO, International Standards Organization. And we'll talk more about those. But again, if I get one point across, and that is simply this: the voluntary standards, as the name implies, they are indeed voluntary, whereas OSHA regulations are law, and therefore they must be respected as law. Now, you don't have to read the text. I provided this right off the websites for both ANSI and ISO. You can read this at your leisure. This gives you the mission statement for both organizations. You'll find that the 2 organizations are highly similar in organization structure, the way they produce and develop documents, how they sell their products, and how they promote their organizations. ANSI could be construed to be a U.S. organization, whereas ISO is an international organization, although ANSI documents are sold internationally, and they're trying to broaden their international appeal. ISO tries to make the point that they are not affiliated with any specific country. But it should be pointed out that many of the more developed countries, such as Germany, Japan, UK, etc., still maintain what's known as home standards, which are generic just to their country, and use the ISO standards on a more global basis. Now, there are some important points of comparison between OSHA and its regulations and the corresponding portions of ISO that relate to this topic. I've already covered the first one, and that is OSHA regulations are actually rules of law. And in the United States, in an injury accident event, a lost time injury accident event, I keep saying lost time, I haven't defined that yet. That means an OSHA 300 reportable event. In that event, the first line of responsibility is the manufacturing company where the accident occurs. Now, this is significant because in the rest of the world, that's not true. The employer is not necessarily the first line of responsibility, and often is not held responsible at all. Equipment suppliers and the individual worker that's injured is typically held responsible. Now, there are, of course, opportunities for third-party litigation in many industrial countries these days, but especially true in the United States. OSHA currently operates at a federal level and via state-organized surrogates. They promulgate the same regulations, but like in the case of the example, state of Michigan, Michigan has what's been abbreviated as MIOSH, and in MIOSH, they take the basic federal regulations and they add on to them. Now, there are other jurisdictions of a county-wide nature in various cities and municipalities that have safety regulations that are additive to. OSHA represents at a federal level the baseline, with other regulations to be tacked on. Now, unlike the other ISO countries, the United States does not participate directly in an NGO operation to develop a safety standard, and that's by policy. OSHA will attend committee meetings on occasion, but their position is they must remain arm's length from the process. They don't produce an NGO standard. They rather concentrate and focus on the application of their regulations. Now, further, the ISO regulations, of course, are considered to be an international document, or a collection of documents, I should say. But if you look carefully at the documents, they certainly have a European orientation and flavor, and it reflects the legal systems that are at play in many other countries. Some of the processes that are not normal in the United States are exercised by other legal systems. One of the most significant one is the loser pays syndrome. And of course, the personal responsibility, holding the victim directly responsible as a first line of responsibility as opposed to the employer. Now, what's interesting is that if there is a third-party claim to be filed, you can tell what kind of uphill battle you have in an ISO country. Because there, you can't sue your employer. And if you take on a machinery builder, well, that's typically a very large company or corporation, and you have to prove that your malfeasance didn't directly lead to your injury. In other words, the burden of proof is reversed. Now, here's the important points of what is not included. First off, ISO does not recognize even the concept of lockout tagout. It does not view it as a procedural imperative, and it's not a safeguard, not in the ISO system. Hardwired emergency stop controls are not mandatory across the board. There is a passing interest in the notion of single point of control. In other words, one man, one control. And the use of RF controlled devices is highly encouraged in the ISO countries, but not necessarily supported by OSHA. And OSHA, in its own regulations, have deemed the physical barrier guarding to be the most effective and direct means of safeguarding an industrial robot application. These are fundamental differences, and these differences must be taken into consideration whenever applying an ISO standard to a U.S. operation. I've said that several times, and it's worth repeating again. I'm only speaking here about the U.S. market. Only in the U.S. market does this presentation have any validity. Outside the U.S., it's a different story. But here in the U.S., as a matter of law, OSHA is prime. And one of the devices that's ubiquitous in the robot business is the teach pendant. Now, it's called by other names for other applications, but a handheld device that is typically cable tethered to the machine and a machine control. It has a modicum of safety devices built in by code, a mid-position enable switch, hardwired e-stop, screen displays for entering data, and a keypad for all manner of robot control and interface. Collaborative robots as well have devices that can be described as a teach pendant, but they have, by ISO standard, different features from those that are conventionally considered to be industrial robot type teach pendants. Now, I've got a small bullet list of items that further explains the function of the teach pendant. And the reason why the teach pendant is important is because it is a safeguard. As a safeguarding device, it provides the ultimate level of safety for personnel working within the restricted zone or the danger zone of the robot, and more importantly, the robot system. And that's a distinction we're going to make today and try to keep it separate. There is robot arm safety and there's robot system safety. Those are two different things. Now let's talk about two collaborative robot injury accidents. I should tell everyone on the webinar that part of my professional activity is to function as an expert witness, and I do both plaintiff and defense work. The collaborative robots have only been, again, in the marketplace, just for the purpose of argumentation, let's say arbitrarily the last 4 years. But already, and I say already, for those that are not familiar with the U.S. system of law, a lot of times cases wind their way through our court system rather slowly. So it's kind of remarkable that here we're probably 4 years into the open marketing of collaborative robots, and I've already got 2 collaborative robot injury accidents. Now, our legal system is also such that there's a degree of confidentiality, particularly for people like myself who work in the case. In this case, actually in both cases, we've not actually filed a lawsuit, so I won't speak to what we're going to file. I suspect it's some sort of wrongful injury accident type pleading, but for the purpose of today's discussion, what's important here, what's critical and fundamental, is the fact that collaborative robots appear to be no different than conventional robots with this one characteristic. Robot arms, and I can't stress this enough, robot arms typically, and I've been in the business 40 years. In my 40-year period, I can tell you, robot arms rarely strike somebody producing an OSHA 300 lost time injury event. More often than not, everything else in the robot work cell may cause an injury, but not the robot arm striking a person. And that's true in the case of these first 2 cases I have. I have them up on the screen in bullet form. One is a material handling application, and the second is a machine tending application. Now again, I cannot speak too much of the detail, but there are some similarities in both, in that neither of these 2 systems were equipped with what I would refer to as a traditional schedule of safety devices, such as safety fence guarding and other secondary e-stop switches and so forth. What's significant here, though, for the purpose of this discussion, is what I just previously stated. In both cases, an injury accident occurred and the arm struck nobody. Now, going to the next slide. And here is the reality. Both companies were cited by OSHA. No different. But for those that have been promoting this theory in the industry that collaborative robots are somehow different, and I heard recently at IMTS in Chicago the opinion expressed numerous times that, well, it's a collaborative robot, therefore OSHA does not apply. Or I don't have to worry about OSHA because it's a different technology. It's improved technology. No. I'm here to make this as clear as I can. From OSHA's perspective, all industrial machinery is the same. There's mechanical parts, electrical parts, computer parts, and OSHA's regulations still apply. In both cases, they were cited under OSHA 1910-212 and 147. As the graphic shows you, 212 is the general purpose machinery guarding standard. And 147 is the ubiquitous lockout tagout standard. Now, what I can tell you, generally speaking, and those who are in the industry might be able to figure out more based on just my general clues, but the material handling application was a situation where there was a partial amputation when someone got their hand stuck in a machine slide device. That was, of course, interfaced with the robot. On the other accident, we had a case of a press loading, but not a stamping press or a real invasive press. I would call it a hot melt press, perhaps. And in this case, the worker was convinced by management that he could get by with just PPE. In both cases, the robot was interfaced. In both cases, in part of the control program, the robot was central. But also in both cases, the robot arm hit nobody. Now, here is something that should be sobering for even colleagues of mine who have been in the industry all these many decades. The website for OSHA was just recently updated. And of course, part of the language pointed out the obvious. Studies indicate that many robot accidents occur during non-routine operating conditions, such as programming, maintenance, testing, setup, or adjustment. And I don't quibble with that at all. That is very true. Production workers typically do not get injured. But here, the next item is the most significant. There are currently no specific standards for the robotics industry. That's off the OSHA website. Perhaps what they meant to say was there are no OSHA robot industry safety standards. I won't speak for OSHA. But the point to be made is simply this. They don't recognize any of the ISO or ANSI standards, those voluntary industry standards, to be robot-specific safety standards for their purpose. When they investigate an accident, it doesn't matter what the technology base is. It doesn't matter what advanced technology the machinery had or did not have. What matters is if they complied with the 1910 collection of safety regulations that apply to all machinery. It's important that this be stressed. You cannot think that because you have a machine vision system or a tactile sensing device or their advanced force feedback sensing, so forth, that then obviates the need to apply OSHA regulations, because to do so is foolhardy, because he who does that process suffers the risk of having a major surprise in the event an accident happens. And this is a good point to point that out. I've been in the safety business, like I said, for 40 years. And it's always said, well, that's if somebody gets injured. That's true. It's like buying insurance policies. It's only applicable if somebody gets injured. But at the end of the day, OSHA's perspective is, please don't show me this ISO standard or ANSI standard or any other NGO standard and tell me you were okay because you complied with that. No, you must comply with our regulations. And oh, by the way, the voluntary standards are also suitable, but not for the purpose associated with a safety violation citation. Now, an alternative to the risk assessment methodologies that are promoted by ISO and ANSI is what's called the OCRA method. The OCRA is an acronym that stands for OSHA-Centric Risk Assessment. This would seem to make a lot of sense, so it's amazing that it hasn't been done before. But a risk assessment based upon what the OSHA regulations require would seem like it make a lot of sense, because at the end of the day, all companies in the U.S. must comply with OSHA regulations. But why wouldn't the risk assessment be OSHA-centric? Seems like it would make sense. A OCRA method is based upon the OSHA regulations and not exclusively on NGO standards. And what that means is that certain aspects of robot safety can still be analyzed and deployed with respect to an NGO standard. But for all safety-related aspects, we're talking something beyond performance standards. For instance, specifying the size and shape, or the thread, or the location purposes, or what have you, for what I would call requirements for use. Well, that's one type of standard. But for safety, you have to go back then directly to OSHA. Now, unfortunately, the LOTO standard's been around for a long time. It always amazes me the number of people who are in the industry, and this includes everybody, lawyers and insurance adjusters, engineers, both suppliers and customers, of just what LOTO really means. Under LOTO, not everything absolutely must be locked out, tagged out, and returned to what's called a ZES, or a zero energy state. That's a fallacy. It never has been true. There are different exceptions to the LOTO provisions, and that leads us to 3 different levels of LOTO: the L1, the L2, and the L3 as shown. And they have 3 different applications. L1 is the most stringent. That's absolute ZES. That's typically applicable when you have major overhaul or equipment relocation or something serious of that nature. The L2 applies to tool changes and modifications. And then L3, excuse me, which is the most common form, it occurs when you have touch-up of programs, or you have changes in like a PLC control that's integrated within the system. But there isn't just one prescription. Unfortunately, because of misinformation or non-information, whatever, the industry has a general belief that when OSHA says lockout, tagout, it means absolutely no power on the machine for any reason, purpose, what have you. And those of us who work in this business, and for 20 years I owned my own manufacturing business and I built systems, we all know that in a lot of cases you must have at least a small modicum of power on to allow you to do the function that you need to do. But there are methodologies within the very long section known as 147 that allow for that. Unfortunately, most industrial users are not aware of them. The 147 regulation is one of the longest regulations in the entire machinery subpart. It runs single-spaced, double column, about 4.5 pages in length. You compare that to the 212 regulation, which is cited almost as often as 147. It runs about 4 inches of text, and that's it. So to say, I know LOTO, that's not a trivial statement because it's very nuanced, very complicated, and provides for a lot of alternative methods and exceptions that most people are not aware of. But again, the OCRA method begins first with OSHA regulations and then adds on any other NGO information that might be appropriate. Now, what does the OCRA method look like? Well, we still use the 1506-1999 standard as a baseline with the same hazard identification methodology, hazard mitigation strategy, and of course, identifying the control circuitry and its duty, and formats for standardizing the documentation. And the OCRA enhancements, of course, is the fact that individual OSHA regulations are scrutinized, and the risk assessment makes an evaluation of whether or not the intended application complies with those specific regulations. Now, within OSHA, and I have not checked on it for this past calendar year, but there's roughly 350 to 360 regulations that get cited annually by federal OSHA. But these 2 regulations, the 212 and the 147, are historically and routinely in the top 10, and typically in the top 5. So it seems like it would make sense if these are the regulations that robot users are typically cited on, that a risk assessment methodology would focus on OSHA regulations that you're going to be cited on. And that's really the biggest enhancement to the OCRA method. And here's the robot reality. I've listed on the screen 3 ISO standards. The 10218, Part 1, Part 2. 1 applies to the robot, the arm, and 2, the system. And then, of course, the collaborative robot standard. What makes these standards inoperable in the U.S. market? There was a concerted effort to make sure that nothing was included about lockout, tagout, or any other U.S. standard. So far, the experience has been in a court of law, and one of those cases is the infamous blood on the teach pendant case. The court, at least in that case, went on the record. And it's a dramatic thing because, as most of us that are on this webinar are probably can testify, these matters rarely ever go to a decision or a verdict. Everybody settles. They're settled out, and there's never a decision. Well, blood on the teach pendant actually resulted in a decision. And a court, in this case, a unanimous 3-judge appellate court in Ohio, ruled that in matters of industrial safety, OSHA predominates and is prime. So it really doesn't matter what NGO standard you follow. The court in Ohio pointed out very clearly the only requirements that are mandated are those by OSHA. So any standard you've got of an NGO type that doesn't have OSHA as part of the standard is, at least in my estimation, inoperable for the U.S. market. Okay, at this point, we'll make a break for any questions in the first half.
If all the attendees can enter the passcode for today. Our first question is, what is a collaborative robot?
Oh, that's a good question. I guess I really didn't address that. Probably the best example I have of that is the definition I received from my colleagues at Yaskawa Motoman. A collaborative robot is a machine that, by design, is used in collaboration with human workers, while the machine is in some form of automatic operation. So that's the generalized description for collaborative. There are some modifications of that. Of course, then there is a description provided in the ISO standard, which you can read verbatim. But the general description is that you can be in the same restricted envelope with the robot during some type of automatic operation.
Our next question is, if I have a collaborative robot, do I need to comply with OSHA?
That's a pretty easy one to answer. If it is a machine operating in a U.S. factory, then you absolutely must comply with OSHA. No exceptions and no other disclaimers. It is a matter of federal law. Like I said before, sometimes also states add on their own requirements. But yes, OSHA makes no discrimination between a collaborative robot and a conventional robot. They're both industrial machines, so therefore the whole canon of OSHA regulations apply.
Also, Vern, we were just having a little issues with sound. Can you just speak a little bit louder, if possible?
Oh, yeah. Is that better?
Yes, that's better. Thank you.
I'm terribly sorry.
The next question is, who is responsible if a collaborative accident occurs?
I'm assuming the questioner means if an accident occurs in a plant using a collaborative robot. It's the same for any industrial accident. The first line of responsibility for all industrial accidents rests with the employer, period.
Next question is, with the CR supply certify that the installation is safe?
Well, I can't say what an integrator may or may not offer for sale or claim, but I think you have to be very cautious in this area because to certify something that's safe and have that stand a legal test in the event of an accident is a pretty tall order. I would take a wary view of anybody who said they could certify something that's safe. If it was done third party, from a third party perspective, let's say a UL certification of some aspect, that's a different story. But generally speaking, that's a foolhardy approach to think that I'm okay just because the integrator said that he could, whatever that means, quote unquote, certify the system as safe.
And our last question for this section is a collaborative robot intrinsically safe? Sorry.
I think you mean intrinsically?
Yes.
Is that intrinsically?
Yes.
I'm not really sure what the question is asking, but I'll just take it at face value. There is no such thing as an intrinsically safe robot. Simple as that.
Okay, thank you. You can continue with the presentation.
Super. And I have to say to the TASA folks, if my volume does drop off, just jump in anytime. That's usually not a problem for me, not normally. All right, now we'll talk about blood on the teach panel. What I've done, I provided a tremendous amount of content over the next 3 slides about this injury accident event. And I'm going to go through each one of these slides and we're going to review them. But what I'll talk about first is an oral description of the application, what happened in this case. And you can always go back and read the detail. But in this case, we have a situation where we have a metal manufacturing company making seat tube products, and they have a variety of custom and special purpose designed equipment, as well as off-the-shelf automation equipment. And in this case, the victim in this case is Mr. Albu. Mr. Albu was a maintenance man working on second shift at this particular plant. And there was a pernicious problem they had with this system. The system was produced by a company called Wayne Trails. And the name of the system, it had a trade name, a flex bender system. It had a habit of having a malfunction over time because of dirt in the die or clamp misadjustment, or it could be product differences, what have you. And it required that someone go into the cell where the tubes were actually being bent and processed and make adjustments. Now, in this particular case, it was the flex bender cell had an outside perimeter fenced enclosure with interlock gates, a master PLC system controller that did the communication for all the devices, including the robot, and a couple of input and output extractor type devices for handling tubes, both the raw tubes and then, of course, the finished product. They had a couple of elaborate servo bending machines to bend the tubes, and then they had a series of presses that provided the dimpling process, which is nothing more than a simple second strike on the tube. Now, in this particular case, this particular cell that was designed by Wayne Trails, they had one little feature that was central to the case on the lower court, and that was one part of the safety fence adjacent to the exit chute out of the work cell was somewhat shorter than the rest of the fence. And it was conceivable that somebody could actually, with some effort, step over that section. And of course, the reason for that was that, and Wayne Trail, of course, confirmed this in their training, if you did not breach the fence at the low point, then you run the risk of shutting the whole system down in an emergency stop condition to enter the work cell through one of the enclosure gates to then service the press in question. Well, of course, that's time consuming and it requires more startup confusion, etc. So, Wayne Trails, when they installed the system, and prior to that, at the runoff at their facility in Fort Laramie, Ohio, they instructed people on how to go in and service these presses. The basic process included breaching the fence, sliding the teach pendant under the fence, the teach pendant for the Yaskawa Motorman robot, and the Motorman robot was the principal material handling device for the work cell. And the operator would then, using the robot teach pendant, sequence a series of outputs as required. Output devices being those control outputs from the teach pendant to make the ram go up and down, to cycle the clamps, do any number of functions. It was a common process. It was done routinely. Mr. Albu had done this numerous times in the past. So there was nothing unusual the night of his accident in that regard. Well, in this case, he was in the work cell with the teach pendant. He got in there through his normal means. And the robot, of course, was perched in a position ready to descend into the press. But since it was in teach mode, it was operating under the control of the teach pendant, which meant that Albu had single point of control, and he had an enabling device that allowed him to control the system, and he was perfectly safe with that teach pendant and the robot. Now, as he's looking at the press, he's going through his procedures of adjusting the clamps, and most of us in the tool and die business know how that works. You clamp it, unclamp it, clamp it, unclamp it. See if you got relative motion, see if you got any pinching, you work it out. So as a consequence of that, he made his adjustments, and after making those adjustments, he was ready to cycle. But prior to cycling, he wanted to check the clamps one last time. But on the teach pendant, which we saw a picture of earlier, he mashed the wrong button. Instead of the 4 button, he hit the 6 button. And what happened at that point, that signal went through the robot control to the PLC to another machine that had nothing to do with what he was working on. But it provided an errant signal, which caused it to come forward and struck him. And the reason why I chose the name Blood on the Teach Pendant is that here he's got this teach pendant. It's a safety device, and he's been trained at its safety. He immediately released the enable switch in the back, mashed the E-stop with his left hand, and almost simultaneously dropped the teach pendant to the floor. But he still didn't stay safe because the machine behind him still got the signal to come forward and strike him. Now, as it sometimes happens, Wayne Trails fought this matter in the lower court for almost 2.5 years, and they had secured a couple of experts, and both the experts that they secured came to the opinion right up front, and they stayed with this all the way through the lower court case, that Mr. Albu was responsible for his accident because he jumped the safety fence. When I was first asked to look at this application, I had to tell Wayne Trails, quite honestly, it did not look like a safety fence case to me because the safety fence had nothing to do with the accident. If this cell was in Japan or China or some other country with more lax safety standards, it could have been running without any safety fence at all, and the accident still would have happened. The accident had to do with other matters, such as lockout tagout. Had nothing to do with safety fence. So as it turns out, that argument prevailed in the lower court. The case never went to trial. As we discussed earlier, they don't. A 7-figure judgment was handed down, and I moved on. But what happened later is that in Ohio, in exchange for intentional tort relief, we have what's called a VSSR, which is another opportunity to get money to an injured worker. It's not an intentional tort, but it's another benefit. In this case, it's a weekly benefit, and it's calculated over some meaningful period. In this case, it was $1,000, and that was reduced to $300 a week, and the term of the payout was $17,200. Well, for the sake of the $17,200, Cameco stayed the course and decided to appeal it. That's how it ended up in the appellate division of the Ohio Supreme Court, and that's what led eventually to the court deciding that even though the same experts came into court and they stipulated the same thing, that the system was built to ISO requirements, ISO regulations, complied with ISO all the way up and down the line, therefore Mr. Albu was at fault. The 3-judge panel in Ohio didn't see it that way. They unanimously decided that Cameco had violated lockout tagout, and Wayne Trail had done the same, obviously, since they're the ones that built the system. The experts stayed the course, and the 3 judges, again, unanimously said no. Now, this is a situation where lockout tagout was not followed to the letter of the requirement, so therefore we do not find for Cameco, and they lost the suit. So, again, in your own leisure, because it's not productive in a webinar to read all the detail. I have 3 different slides here that, again, summarize what I just talked about. The important takeaway to this is simply this. At least a court in Ohio has ruled on it most succinctly. In matters of industrial safety, OSHA predominates. It doesn't matter if you claim you're ISO compliant and you spend all kinds of time and money and effort to demonstrate your ISO compliance, your ANSI compliance. It really doesn't matter. If you don't comply with OSHA, that's all that matters. Okay. Again, you can read the individual detail. And this is the iconic photo that came from the accident. This is the teach pendant for the Yaskawa Motorman robot. Yes, that is what you think it is on the top of the teach pendant. It was unfortunate. Mr. Albu relied upon that teach pendant, but had the company, either Cameco or Wayne Trail, either one, had followed OSHA requirements under lockout tagout. There's a specific regulation under the 147 requirements that stipulates that any other hazards in a work area during a maintenance process that are not involved with that operation must be locked out. In the case of this application, not only was this other offending machine not locked out or tagged out, because it was a custom designed machine, it didn't even have a lockout hasp or an opportunity to allow for that. They didn't design it in. So, going forward, OSHA comes first. Okay, and I summarized those facts, okay, in this following slide. And once again, you have to consider that if you do an OSHA-Centric or an OCRA risk assessment process, all of this will fall out. Now, here we go into some of the, time for a disclaimer again. I am not a lawyer, and I am not licensed to practice law. So anything I provide here is not a legal opinion. It's strictly a technical opinion that I've gained from over 20 cases in this matter, or in these matters rather. Of course, one of the conundrums to the whole risk assessment process, as it's expressed by ISO, is that if an injury accident occurs, then you have logical questions. Did you or anyone else create a formal risk assessment? Well, it's problematic, and I'm speaking here to both defense counsel and plaintiff counsel. It can be problematic either way. If you say, yes, you have one, well, now you're going to be forced to defend it. Because it's obvious if you had it, an argument can be plausibly made that it was defective because it didn't work. And the reason why you can say it didn't work is because someone got injured. Now, if you say no, then you have to acknowledge the fact that you overlooked the requirement. And under OSHA, OSHA does not use the language risk assessment document, but they say that all risks must be assessed. It doesn't take a great wordsmith to craft that into the proper question. So did you assess the risk, or in other words, did you do a risk assessment, either one? Now, a common answer is number 3, I don't know. Again, I'm not a lawyer, I don't practice law, so I'm not going to tell you how valid that response is. But the risk assessment is a two-edged sword, so it must be done right. Now, as far as the follow-up questions, the thing that you must be concerned with is what methodology you chose. Is the process documented? And I highly recommend, it really doesn't matter what side of the bar that I'm on, that this will be done in a group effort. But what's disturbing with this is the approach that you see with these two questions. I'll let you read it. What we have not talked about to any great degree is third-party litigation. Well, if you are found to be cited by OSHA, that's already, again, not speaking from a legal perspective, but purely technical perspective, it already becomes a fact that you violated the law. Once you've broken the law, that's when you have to protect yourself from the third-party litigation. Because the case has been made, you already broke the law, so therefore, how culpable are you for damages? So, this must be considered whenever you consider doing a risk assessment that's anything other than OCRA in nature. If you do an ISO risk assessment and you follow that process, or you follow the processes from ANSI, that's all fine and good, but it better include lockout, tagout, it better include physical barrier guarding, it better include those things that OSHA holds dearly, or you have the risk of having additional damages occur because of third-party litigation. Now, this is why it's the subjective nature of ISO risk assessment. What I have on the screen here is those three characteristics we talked about earlier of how the robot safety is adjudicated based upon the avoidance and the frequency and severity. Avoidance, how easy it is to get away from the accident. Frequency, how often are you exposed to the hazard. And severity, is it a serious injury or not? All three of those factors are highly qualitative in nature. All three of them vary. Any two inspectors, or any five inspectors for that matter, can come up with a totally different opinion because, again, it's qualitative. Now, you'll notice if you go from left to right on the chart, you see how you then try to determine what safeguards to select. No. The more appropriate approach is the OCRA approach to say, what must be locked out? When does that machine have to be locked out? And what are the procedures to both lock it out and then return it to service? And by the way, this is one chart. Over the years, there's been permutations of this, but the basic process remains the same. You have essentially three characteristics. I have no idea where the three characteristics came from, but they appeared sometime in 91, 92. And again, it comes down to the avoidance, severity, and frequency. Now, I'm sure there's people on this call are saying, there's a lot more to it than that. It's not just those three characteristics, and that's true. But yet, this same process survives year after year, and everybody accepts it as fact. But if it does not include, in the U.S. market, allowance for OSHA regulations, then it's not effective. Now, here's something that should chill any of the insurance lawyers that are on the call, and any of the engineers that have to do this work. One of the things that the ISO people are very, very fond of is applying personal assurances, personal responsibility to this risk assessment method. You'll notice in the standard report here, risk assessment report, you notice there's a place for someone to sign. Well, from the ISO legal perspective, of course, you have somebody who's an engineer and he designed the safety, and so he fills out the risk assessment and he signs it. Of course, when that comes into the U.S. court of law, that's a little more problematic. I don't know too many engineers who are willing to sign their name to a risk assessment report where they personally take responsibility for the efficacy of that system. Because you're taking responsibility for regulations that you don't promulgate, that you don't control. You're just parroting back what an integrator has given you or some other robot professional. I really think that this, of all things, is going to be most problematic for the ISO risk assessment. Because the first time that in my industrial experience of 40 years, that we've had an organization simply say, personify this. It's not XYZ company. It's Fred or Barney as an individual. That changes the process. But this is the ISO way. And if you're not aware that it's the ISO way, go to the 10218 or any of the ISO documents, and you'll see that a personal level of responsibility is part of the process. All right. I'm not going to go into a whole lot of blocking and tackling, both because of the interest of time but also simply to say that for both parties in litigation, it's been my personal experience that being mindful of U.S. law and U.S. requirements should be important for either side, regardless. It's unfortunate that because of a lack of education or information or reasons that I can't personally divine, we have come to assume that if it says ISO International, it must be better. We talk about ISO 9000, ISO 12000, 14000, various ISO systems that are global in nature, and everybody signs on to it and everybody's happy. Well, that may well be true. For quality purposes, for accounting purposes, maybe that is true. But in the business of industrial safety, there is no exception and no substitute for compliance with OSHA regulations. Again, blocking and tackling. The centerpiece of these cases now, much like the blood on the teach-bended case, and these two collaborative cases I'm on right now, I'm sure, is going to come down to this risk assessment document. There is a certain mythology within the robot industry in the States that's developed in the last 20 years that everything is okay, everything is all right. You can do anything you want as long as the risk assessment says it's okay. As long as you manipulate the risk assessment to say what you want to say, you're okay. That's absolutely and fundamentally not true. Because you can do whatever you want in a risk assessment and make whatever case you want in a risk assessment, but when the inspector comes in to look at the scene after an injury, accident, event, they're going to go back to the 1910 CFRs, and you're going to be judged by what the regulations say, not by anything that you or integrator or supplier has put in a risk assessment. If there's anything I leave the group with today, it's simply that. You cannot rely upon a risk assessment document to do your safety homework for you. In the presence of a risk assessment, no matter how much time and effort you put into it, no matter how much detail you committed to it, no matter how earnest you were, it doesn't matter. OSHA does not care. Oh, they care that you care enough to care yourself. That sounds kind of convoluted. But at the end of the day, when it comes time to write a citation, they're going to write you a citation based upon 145, 132, 136, 212, 147, any of the top 10 that apply to an injury accident event with a robot. So again, I believe you one thing for sure, and that is don't rely upon the risk assessment methodology. Now, there are some different ways of attacking this. One way is third-party certification. Rather than do a risk assessment on your own, you can have that contracted out or have other third parties. Among the NGOs, I think the most progressive and most dynamic of NGOs is the American Welding Society, the AWS, based in Miami, Florida. They've actually done something that no other robot organization in the world has done. They have created a certified robot arc welder credential to certify individuals, and one of the main aspects of the certification is safety. And one thing that AWS is not shy about, they embrace OSHA and OSHA requirements, and OSHA is codified in the AWS documents. What I got on the screen here is a picture of an actual credential. You go through the AWS program on robots. Now, I must admit, for those that are listening, it's a fairly narrow certification program and it involves arc welding robots. That is a large installed base, don't get me wrong. But here I'm talking about the methodology. To take a body of experts, produce a consensus document, and then tie that into OSHA, and then produce a testing process to test individuals to certify them as being ready for robot arc welding. That's another possible opportunity. I think you're going to see more third-party certification arise. AWS is expanding their third-party certification to include other forms of material handling and material joining, most notably TIG welding, resistance welding, etc. But that's just one approach. That wraps up the technical content. Take this opportunity to take any other questions you might have.
Sure. If all the attendees can enter the passcode. Our first question is, can we get more detail about the two cases where these force limited robots, were these related to in-arm tooling coming in contact?
No, that's a great question because I've got to make this as clear as I can. The robot arm had nothing to do with either collaborative injury. Now, to the limits of what I'm allowed to talk about, because I have to remain in confidence, let me simply say, okay, in the one case, you have an operator positioned in front of the robot arm. The robot arm performs a function, and this individual was doing a follow-on material handling function, and it was facilitated by a two-rod, cylinder-actuated shuttle mechanism. This individual, and I won't say whether it was man or woman, I don't want to give too much away, but as sometimes happens, accidentally caught their hand in the slide mechanism, but the robot had sent the signal to cycle that mechanism. So therefore, by design and by definition, it is a robot application. And no, the force-limited robot arm, once again, this is a great question, had nothing to do with it. Now, the other application, in a similar sense, the force-limited robot arm, and editorially speaking, there's two different robot companies, by the way, in case anybody's curious, two different robot companies. They're very credible companies, and I'm sure they make fine products, etc. But the other one, I call it a press application only because that's the only language that makes sense. But I don't want to conjure in anybody's mind a large four-masted hydraulic press type device. No, it's a small, let me describe it like this, a hot melt press, for lack of a better term. And once again, nothing malfunctioned, nothing failed. It was simply used improperly. But in both cases, it's a robot application. In both cases, all the equipment's integrated together into one common control. In both cases, the force-limited, highly sophisticated, and really elaborate state-of-the-art collaborative robot didn't strike anybody. But in both cases, it had a 300 reportable injury event. And OSHA, it's a kind of a form of procedural discretion. They felt it was severe enough in either case. Two different OSHA guys, by the way, came to the same conclusion with respect to their individual cases, that it did warrant a citation. And interestingly enough, both companies were cited, and the two cited was 212 and 147. So let me make real clear, and it's a great question. I don't know if we get brownie points for good questions, but that is a great question. Let me make this abundantly clear. In both collaborative robot injury accident events, the arm didn't strike anybody. So thank you. It was a great question.
Next question is, do you anticipate that self-driving trucks, etc., might be considered as a CR, collaborative robot, by OSHA?
Okay, on the question on the autonomous vehicles, we've had AGVs operating in plants. I did my first AGV, kind of robotic AGV control for Pechenay, an aluminum company in France, back in the early 80s. So this technology has been around for a long time. Now, with respect to RF control and the control of these devices within a plant, often what gets cited is the overhead bridge crane RF model. But as we've determined in the safety business, the overhead bridge crane RF control has alternative safeguard methodologies. It's true for any RF automatic control vehicle. You have to take a look at what type of safeguarding totally that you have. And I think sometimes we get confused by saying there's things that we can do, but are these things that we should do? It's the can and the should part of it. OSHA has already been involved in cases involving AGVs. And I would have to say, at the end of the day, that OSHA has, once again, trotted out their regulations, as they should, and they've applied a strict reading of OSHA regulations, which would imply that you must have some effective means of alternative safeguards. In other words, the same rules that apply to a stationary piece of machinery or a robot on rails or a robot on a shuttle or what have you, the same thing applies if there is no shuttle tracks per se. You must have the same sense of safety that you would otherwise. So, to say whether OSHA is going to come out with specific recommendations, the only thing that I've discovered in OSHA that is extremely specific, and this really makes no sense, it's a historical thing, the matter of ladders. Ladder specifications under OSHA are highly defined, very specific. Towboats, angles, pitch, distances is incredible. For some reason, someone must have had a problem with ladders 20, 30 years ago, and that's really specific. Will they produce specific rules? What will happen if we get a bumper crop, as it were, of a lot of accidents of that type? Then OSHA will put together a committee and will pursue it. As I can tell right now, there really is no interest in that level. But if it's inside the four walls of a factory, then yes, it'll fall under OSHA's purview, and they will write the rules. Good question. Very good question.
Okay, thanks so much for answering those questions. In addition to being your best source for testifying and consulting experts for the past 60 years, TASA also offers e-discovery and forensic solutions, free interactive webinars, cybersecurity services, and day-in-the-life videos. We also offer research reports on expert witnesses, example, the Challenge History Report 2.0, the Preliminary Screening Report, and Expert Profile 360. I want to take this opportunity to thank everyone for attending, and most especially Vern Mangold for his time and effort in creating this presentation. If you'd like to speak with Vern, or if you'd like to speak with a TASA representative regarding an expert witness for a case that you're working on, please contact TASA at 1-800-523-2319. One of my colleagues will be following up with you regarding your feedback on today's presentation. This concludes our program for today. Thank you for attending.